Give me 1 second. All right. So we talked about transistors. We said that there are two types of transistors as PNP transistor and NPN transistor, right? So, අපි චුට්ටක් ආයම මුලින් ඉඳන් කතා කරමු. What did we exactly learn in transistors? We will talk a bit and then we will move on to today's part, right? අපි කිව්වා if we get a PNP transistor, we know that in the two corners we have P and at the middle we have N, right? Then we know that there are three terminals coming from the three semiconductors, like this, and like this. What do we call this middle terminal? What do we call this middle terminal? Yes, we call it the base. And as a symbol, you can even use capital B, right? Then මෙයාවම මර මේ විදිහට අදින්න පුළුවන්. Like in the circuit, I don't draw it like this, right? In the circuit, how do I draw? I draw a circle. Then I draw this little part like this. From this arises one terminal like this. Then මෙහෙම. මෙහෙම. Again, we know that this is the base. My capital B කියලා විතරක් දාන. Now you know capital B is base, right? I told you as a rule, මොනවාද මම කිව්වේ, if we talked about this, we said, first let's write that this is the emitter. දෙපැත්තෙම තියෙන P නේ. ඒතර දෙනගේ එක්කෙනෙක් becomes emitter, the other one becomes collector. The other one becomes collector. So we know as a rule, charge carriers move from emitter to collector. Emitter is a P semiconductor. What are the charge carriers in the emitter? What are the charge carriers in the emitter? Holes. So because of that, we know charge carriers move from emitter to collector. Then emitter එක තියෙන P semiconductor එකක්නේ. ඒකේ තියෙන holes. Therefore, holes will move from emitter to collector, and you know holes are positively charged. Then can you tell me the direction of the current? What is the direction of the current? Emitter to collector or collector to emitter? Yeah. Yes. Holes තියෙන direction එකටම තමයි current එක යනවා කියලා කිව්වේ. So current goes like this. ඒතර current එක emitter to collector නේ යන්නේ. Emitter to collector යනවා කියන්නේ emitter එක ඇතුල් පැත්තට යන්නේ. Emitter එකෙන් ඇතුළටනේ. I hope you understood that. Emitter එකෙන් ඇතුළට යන්නේ. Therefore, I draw the arrowhead like this. ඔයා හදිස්සියෙන් මෙතන arrowhead එක ඇන්දොත් this becomes the emitter. ළමයි හැම වෙලෙම යට emitter එක තියෙන්න ඕන, උඩ collector එක තියෙන්න ඕන කියලා එකක් නෑ, right? එහෙම එකක් නෑ. Always arrowhead එක තියෙන කෙනා emitter. Wherever the arrowhead is, the terminal with the arrowhead is the emitter. If the arrowhead is into the transistor, that is a PNP transistor, right? So මේ විතර එන්නත් පුළුවන්. අපිට දැන් හුරු එක අපි ඇහැ හුරු කරගන්න ඕන එක හින්දා මම අනිත් පැත්තට මේක අඳින්නම්, but ඕනි පැත්තකට එන්න පුළුවන්. So arrowhead එක තියෙන එක්කෙනා emitter, the other one automatically becomes the collector. So this is a PNP transistor. Now let's talk about an NPN transistor. NPN transistor ke base එක N the P the. Is the base an N semiconductor or a P semiconductor? Others, what do y'all think? ළමයි ඕගලන්ට වෙන වෙනම Saturday class එකේ මම වෙනම ටිකක් පාඩම් කරන්න දුන්නා. Sunday class එකේ වෙනම ටිකක් පාඩම් කරන්න දුන්නා in biology, I suppose. ඒවා මම මෙතන කතා කරන්නේ because we combine the two classes. We will talk about those in the individual like Saturday and Sunday classes, right? Yes, as you all correctly said, the base is P conductor, right? P, not N. I P ne madde inne always madde inne kenane base එක. So P semiconductor is the base. That means here this is the base. And I will say that this is emitter, this is collector. And as you know, charge carriers always move from emitter to collector. Now, with an emitter N semiconductor එකක්. So what are the charge carriers in this emitter? What are the charge carriers in emitter? Yes, electrons. In emitter to collector කොහොමත් හැම වෙලේම charge carriers යනවා. In this particular case, since emitter is N semiconductor, there are electrons. Electrons are negatively charged. Then what is the direction of the current? Is it from emitter to collector or collector to emitter? අනිත් අයත් උත්තර දෙන්න ළමයි. Everybody answer. වැරදුනාට කමක් නැහැ. Right? වැරදුනොත් ඉතින් you correct it. Yes, correct. It's emitter to collector. Current is from emitter to collector. ඒ කියන්නේ emitter එකෙන් එළියට නේ current එක නෙමෙයි. emitter එකෙන් එළියට තමයි current එක යන්නේ. ඒකින්ද ඔයා මෙහෙම එළිය පැත්තට තමයි arrow head එක දාන්නේ. ඔයා මේක මෙතන දාන්නත් පුළුවන්. arrow head එක මෙතන දැම්මොත් this becomes emitter and this becomes collector. අපිට ගොඩක් familiar අනිත් එකකින්ද මම අනිත් විදිහට ලියනවා but අර එහෙම එන්නත් පුළුවන්. So arrowhead එක එළිය පැත්තට එනවා කියන්නේ that is always NPN semiconductor. And I think we wrote a small description as well. We said charge carriers always move from emitter to collector. Because of that, current always moves in the respective directions. In PNP semiconductor, current moves from emitter to collector. It can arrowhead එක එන්නේ inverse. NPN semiconductor එක current moves from collector to emitter. It can arrowhead එක outwards, coming outwards of emitter. And arrowhead එක තියෙන terminal එක තමයි හැම වෙලෙම emitter කියලා අපිට identify කරන්න පුළුවන්. I think that's where we stop, no? Is that right? Okay. Sunday class එකකටත් මම අන්තිමට කියලා notes ටික දැම්ම group එකට ඒකෙන් ලියා ගන්න කියලා නේ. Okay. I think we can move on with the today's part. Before we explain today's part, we will start with writing a small note. මොකද මට මේ note එකේ points ටික ඕනේ ඔයාලට point by point explain කරන්න. Okay, let's start writing. Put a subtopic, biasing a transistor. Biasing a transistor. Metika, don't worry about it. Just write with me. After this, after writing, I will explain with the diagram. Collector, reverse biased. Well, first of all, write these points. After you write these points, I will explain with the transistor pictures, right? Quickly write. Quickly write. So Paraquilla join what we were doing was that last day we were discussing about the PNP transistor and NPN transistor. We just went over it only. Like we just revised that one more time and then we only wrote this. I didn't explain this yet. And I asked you all to first write this, then I will explain it. Make it fast. Lama, a small something while you write this. Ogalang කවුරු හරි මගේ recordings request කරලා තාම හම්බු නැති අය ඉන්නවා නම් let me know. Emoji එකක් දාන්න. Then I will send those. I'll give you 2 more minutes. done lamai? Okay. Others? What about others? Okay, I think that's enough time, no? Hard. Then අපි මේක apply කරලා බලමු අපි දන්න transistors දෙකට, right? So, first of all, these are the rules of biasing a transistor. What is biasing? Now, let me just do a quick revision. I hope you all remember diodes and how we biased diodes, right? අපි මෙහෙම ගත්තොත් diode එකක් like this. And let's say there are two different ways how we can connect this diode to a circuit, right? Like this or like this. I will label this circuit as circuit A and I will label this as circuit B. In which circuit will there be a current flow? In which circuit will there be a current flow?
A.
Okay, A. I got in the chat box also A and B both. Others? Nudam, Randira, Manisha, Situki, Oneli, Muni, Sehasha, Dinugi, Ashwini. In both. Setumini, Fatima, Disal. Lamai. Current, this is the positive terminal and this is the negative terminal, right? So current will ideally flow like this. මෙහෙමනේ current එක flow වෙන්නේ. Current එක flow වෙන direction එකටම නම් diode එකේ arrow head එක තියෙන්නේ. We call it forward bias. Forward bias. Forward bias වෙද්දි විතරයි current එක flow වෙන්නේ diode එකක් through. Once again, forward biased. Let's look at this instance. The current is supposed to flow in this direction. හැබැයි current flow in a direction එකට නෙවෙයි diode එක arrow head එක තියෙන opposite direction එකට. Current එක කියන්නේ මෙහෙම diode එක arrow head එක තියෙන මෙහෙම. That is reverse biased. ඒකින්ද ඒක ඇත්තටම current එකක් නෑ. Current එකක් flow වෙන්නේ නෑ. This is reverse biased. If you can't remember, you have to go back to that lesson, back to when we did this part and revise. What is forward bias and what is reverse bias? Whether it's a diode or a transistor, biasing means that we are arranging the terminals in such a way that there will be a current flow. That is biasing, right? So let's look at this these sentences. මම මේක apply කරන්නම් PNP transistor එකට මුලින්ම, right? So let me first draw a PNP transistor. This is the base, right? This is the collector. This is the emitter. How do we know that this is the emitter? Because there is the arrowhead, right? Onna mama and the PNP transistor, right? Now I'm going to apply whatever is given here, right? Okay. Api sentence read karmu. Emitter base junction should be forward biased. Emitter base junction should be forward biased. Okay, චුට්ටක් තියන්න. Base collector junction should be reverse biased. ඒකේව කොහොමද වෙන්න ඕන? Forward the reverse the M කියලා තමයි තියෙන්නේ. ඒකත් පොඩ්ඩක් තියන්න. Third එක බලන්න. Current should flow between C and E in the direction indicated by the arrowhead. C and E අතර current එක flow වෙන්න ඕනේ arrowhead එක තියෙන direction එකට. Okay. So let's look at our PNP transistor. C and E connect වෙන්න ඕනේ විදිය. C and E connect වෙන්න ඕනේ so that current will flow in the direction of the arrowhead. Arrowhead එක තියෙන්නේ මෙහෙමනේ. මේ පැත්තට තමයි arrowhead එක තියෙන්නේ. ඒ කියන්නේ current එක flow වෙන්න ඕනේ මේ පැත්තට නේද? මෙන්න මේ direction එකට තමයි current එක flow වෙන්න ඕනේ. Did you understand that? The current should flow in the direction of the arrowhead. ඒක තේරුණාද ඔයගලන්ට? So, if the arrowhead is marked like this, මෙහෙමනම් arrowhead එක mark වෙලා තියෙන්නේ A direction එකට තමයි current එක flow වෙන්න ඕනේ. මෙන්න මෙහෙම. A direction එකට current එක flow වෙන්න නම්, do you understand that I should connect my dry cell like this? Then මෙයා තමයි positive terminal එක, මෙයා තමයි negative terminal එක. So, current will actually flow in this direction. Current will actually flow like this and it will match the direction shown by the arrowhead. Did you all understand that part? Mom, ekinne kahanne because it's very important. Give me a thumbs up if you understood. And if you have any questions, please let me know in the chat box. Sehasha, Senet, Setumini, Situki, Randira. Batula, do you have a question or is it clear? Okay, all right. Hari. ඔන්න එහෙනම් ඒ ස්ටෝරි එක හරි. මම arrowheads ටික erase කරන්න. Now let's look at the first point. Emitter base junction should be forward bias. Emitter base junction should be forward biased, right? මම මෙන්න මෙහෙම එකක් කරනවා. හරිද? Something like this. Here. Base එකයි emitter එකයි දැන් connect වෙන්න ඕනේ. මෙන්න මෙහෙම. It should be forward bias. ළමයි PNP transistor එකක, this is a PNP transistor no. Emitter කියන්නේ N semiconductor එකක්ද P semiconductor එකක්ද? Emitter. Is emitter a P semiconductor or an N semiconductor? Yes. Emitter කියන්නේ P semiconductor එකක් and you know base කියන්නේ N semiconductor එකක්. You know forward bias වෙන්න නම් in a diode, right? In a diode forward bias වෙන්න නම් N semiconductor එක negative terminal එකට connect වෙන්න ඕනේ, P semiconductor එක positive terminal එකට connect වෙන්න ඕනේ. N semiconductor should be connected to the negative terminal of the dry cell. P semiconductor should be connected to the positive terminal of the dry cell. එතකොට තමයි forward bias වෙන්නේ. එහෙනම් මෙතන base is an N semiconductor no. So it should be connected to the negative terminal. Emitter is a P semiconductor no. So that should be connected to the positive terminal. ඔන්න එහෙනම් base එකයි emitter එකයි forward bias කරා. So this is forward biased. Make a තේරුණාද? Did you all understand this one? Thumbs up, thumbs up. And if not questions, you can ask in the chat box. Nudam, Muni, Micheli, Imasha, Fatima. Okay. Onne ekhat hari. Right, ekhat hari. Let's look at the second point. Second point එකේ කියනවා base collector junction should be reverse biased. මෙතන ළමයි අපි ගොඩක් වෙලාවට base එකයි collector එකයි connect කරන්නේ නැහැ wire එකකින්, right? Connect කරන්නේ නැතුව අපි බලමු නිකන්. Without connecting we'll just see. You know base is an N semiconductor. Collector කියන්නේ N එකක්ද P එකක්ද? Is collector an N semiconductor or a P semiconductor? P. P semiconductor, right? So here, make a බැලුවොත් එහෙම ළමයි, you know forward bias වෙන්න N semiconductor එක negative එක්කෙනෙකුට connect වෙන්න ඕනේ, P semiconductor එක positive එක්කෙනෙකුට connect වෙන්න ඕනේ. Here base is N and it is connected to a negative terminal, that is okay. But collector is P type semiconductor, it is also connected to a negative terminal. එතකොට forward bias නෙවෙයිනේ, because P semiconductor should be connected to a positive terminal. ඒකින්ද අපි generally consider කරනවා මෙයා reverse bias කියලා. අපි මෙයා reverse bias කියන එකම හේතුව මෙතන current එකක් යන්නේ නැති හින්දා. Because there is no proper current flow here, we call this reverse bias. හැබැයි අපි එක connect කරන්නේ නැහැ wire එකකින්. සමහර වෙලාවට only we connect it. Generally we don't connect it, right? We say this is reverse bias. The only reason why we call this reverse bias is because there is no current flow. Current flow එකක් මෙතන නැහැ. අයි current flow එකක් නැත්තේ. N semiconductor එක නම් negative terminal එකකට connect වෙලා මේ පැත්තේ. But C semiconductor, which is a P-type semiconductor, is supposed to be connected to a positive terminal. හැබැයි යාත් connect line negative terminal එකට. ඒකෙන් මෙතන current flow එකක් නැහැ. ඒකින්ද අපි wire එකක් දාන්නෙත් නැහැ එතනට. We just call it reverse bias, right? So PNP transistor එක බලමු. PNP transistor C should be connected to the positive terminal. හරිනේ. What? 1 second, there is a small error. අපි note එකේ චූටි දෙයක් හදාගන්න. This should be connected to the negative terminal. This should be connected to the positive terminal. C should be connected to the negative terminal and E should be connected to the positive terminal. This should be the other way around. Nah? That's a little typo. I'm very sorry for that. ඔයගොල්ලන් erase කරගෙන පොඩ්ඩක් හදාගන්න ළමයි මේක. මෙන්න මෙතන positive negative වචන දෙක. Quickly correct it. හරිද? Okay. So in both in the last one, right? දැන් මෙතන කියනවා PNP එක C should be connected to the negative terminal. That is true. C is connected to a negative terminal. E is connected to a positive terminal. So E is connected to a positive terminal. ඒකත් හරි. Last again, both B is given a voltage in the same direction as C but with a smaller magnitude. ඒ කියන්නේ දැන් මේ outer circuit එකේ current එක කොහමද යන්නේ? මෙන්න මේ direction එකට. කොහොමද current එක යන්නේ? ඒ කියන්නේ මෙන්න මෙහෙම තමයි යන්නේ. emitter එකෙන් ඇතුළට යන විදියට, right? Base emitter ගත්තොත් එතනත් යන්නේ emitter එකෙන් ඇතුළට current එක යන විදියටනේ. Circuit එක මේක positive terminal එකනේ. So දෙකේම current එක යන්නේ එකම direction එකට. හැබැයි මෙන්න මෙතන voltage එක මෙතනට වඩා අඩුයි. Let me explain that one more time. If you look at the outer circuit, the big circuit, you can see මෙයා positive terminal, මෙයා negative terminal නේ. So current එක යන්නේ මෙන්න මෙහෙම. So current goes inside emitter. Emitter එක ඇතුළට යන විදිය තමයි current direction එක යන්නේ. මෙතන ගත්තොත් මෙයා positive මෙයා negative, here also current එක යන්නේ ඒ direction එකටම තමයි. Okay, emitter එකෙන් ඇතුළට යනවා වගේ. In both the direction is the same. හැබැයි මේ voltage එකට වඩා මේ voltage එක අඩුයි. The voltages are different. Excuse me. The voltages are different. Is that clear? Make a තේරුණාද ළමයි? Give me a thumbs up if it's clear. If it's not, you can ask me questions. Ashwini, Dinugi, Mikeli, Nudam, Situki, Yansilu. What does that mean, Yansilu? Current is different? What do you mean? The question is not clear to me. Voltage. මෙතන voltage එකට වඩා මෙතන voltage එක අඩු වෙන්නේ ඇයි කියලා we will see in the future applications. ඒ කියන්නේ transistor එක සාමාන්‍යයෙන් අපි transistor use කරන එක reasons තියෙනවා, right? When we are using a transistor, එක application එක තමයි amplification කියලා කියනවා. Right? ඒක ඉස්සරහට තමයි explain කරන්නේ. මම චුට්ටක් නිකන් කියන්නම් to answer that question. Amplification කියලා කියන්නේ ඔයා චූටි current එකක් දෙනවා transistor එකට. transistor එකෙන් ලොකු current එකක් කරලා එළියට දෙනවා. එතකොට අපි සාමාන්‍ය චූටි current එක දෙන්නේ මෙන්න මේ circuit එක. එයා ලොකු current එකක් විදිහට produce වෙන්නේ මේ circuit එකේ. ඒකෙන් සාමාන්‍යයෙන් base emitter එකට අපි චූටි voltage එකක් තමයි දෙන්නේ. එතකොට මෙතන ලොකු voltage එකක් එනවා කියලා. ඒ කියන්නේ generally this is how we connect it, but you will see in applications. So transistor applications here, signal amplifier, current amplifier, switching action switching action කියලා තව එකක් තියෙනවා, right? ඒව වලදී ඔයගලන්ට තේරෙයි මෙතන තමයි හැම වෙලෙම පොඩි එක්කෙනා. මෙයා තමයි ලොකු එක්කෙනා. අපි මේකට තව නමක් කියනවා, we call this the input circuit and we call this the output circuit, right? So in the applications, I will explain it one more time. But for the moment, just remember, මෙතන voltage එකට වඩා මෙතනක අඩුයි. ඇයි අඩු වෙන්නේ කියලා you will see in the applications. Okay, Silu? Okay. So අපි මේකම use කරමු NPN transistor එකට. So there was a question. Yes, if you don't mind, can you explain this whole thing again? Yes, of course, I will explain this one more time, right? This is a PNP transistor, right? අපි දැන් මේ rules ටික apply කරන්න ඕනේ. මුලින් මම කිව්වා we will look at the third rule. Current should flow between collector and emitter in the direction indicated by the arrowhead. Arrowhead එක තියෙන ඇතුල් පැත්තටනේ. එහෙනම් ඒ direction එකට හරියන තමයි අපි battery dry cell එක connect කරන්න ඕනේ. current එක ඇතුල් පැත්තට නම් මෙන්න මේ විදිහට තමයි current එක යන්න ඕනේ. So current එක හැම වෙලේම යන්නේ positive terminal to negative terminal නේ. එහෙනම් this should be the positive terminal and this should be the negative terminal. එතකොට තමයි ගානට current එක ඒ direction එකේ යනවා කියලා අපිට කියන්න පුළුවන්. That is the first one. හරිද? Then they say emitter base junction should be forward biased. Emitter එකයි base එකයි බැලුවොත් you know base is an N type semiconductor, emitter is a P type semiconductor. Forward bias කියලා කියන්නේ හැම වෙලෙම N semiconductor එක negative terminal එකට connect වෙනවා, P semiconductor එක positive terminal එකට connect වෙනවා. Here base is N type semiconductor and it should be connected to a negative terminal. Emitter is P type semiconductor, then it should be connected to a positive terminal. මෙහෙ මේ විදිහට ඔයා dry cell එක connect කරොත් that will be forward biased. හරිද? Then base collector junction should be reverse biased. මේක reverse bias කියලා කියන reason එක මෙතන current එකක් flow වෙන්නේ නැති විදිහට තමයි අපි හදලා තියෙන්නේ. කොහොමද? base එක N type semiconductor එකක් එයා මෙතන negative terminal එකකට connect වෙලා ඉන්නවා. ඒක හරි. හැබැයි collector එක P type semiconductor එකක් එයා මේ පැත්තේ positive terminal එකකට connect වෙලා නැහැ. එහෙනම් forward bias වුණොත් විතරනේ current එක යන්නේ. Only if it's forward biased will current flow. Right? Forward bias වෙන්න නම් N semiconductor should be connected to negative, P semiconductor should be connected to positive. මෙතන එහෙම නැහැනේ. මෙතනෙම නැතිනම් එතන current එකක් නැහැ. ඒකින්ද අපි මෙතනට මෙහෙම wire එකක් දාන්නෙත් නැහැ. අපි කියනවා current එකක් නැති හින්දා we just call it reverse biased. Right? Accordingly, in PNP transistor, C should be connected to a negative terminal. C should be connected to a negative terminal. E should be connected to a positive terminal. ඒක තමයි අපි දැන් ඉස්සෙල්ලා කතා කරේ. මොකද එතකොට තමයි මේ පෙන්න direction එකට current එක යන්න පුළුවන්. Right? In both, B is given a voltage in the same direction as C, but with a smaller magnitude. බලන්න ඔයා මේ ලොකු circuit එක ගත්තොත්, if you take the bigger circuit, make a positive terminal එක, make a negative terminal එක, so current flows like this. එම emitter එකෙන් ඇතුල් පැත්තට තමයි current එක යන්නේ. Right? Then if you look at base and emitter junction, මෙයා negative, මෙයා positive. ඒකෙත් current එක flow වෙන්නේ මේ direction එකට. emitter එකෙන් ඇතුල් පැත්තට, right? Like this. So in both the circuits, the direction of the current flow is the same. කියන එක තමයි ඒකේ mean කරන්නේ. හැබැයි මෙතන voltage එක අඩුයි, මෙතන voltage එකට වඩා. Okay. So ඒක අඩු වෙන විදිය මම applications NPN transistor එකට අපි ඉවර කළේ. Right? Then before the applications I will explain that. Mune, is it clear? Do you want me to explain again? Clear, no? Okay. Let's look at an NPN transistor and we'll apply the same things. Make a current එළිය පැත්තට තියෙන. Right? So, this is the base, this is the collector, and this is the emitter. ඔන්න මේකටත් මම එකම තමයි කරන්න හදන්නේ. මොකද්ද? Current should flow between C and E in the direction indicated by the arrowhead. C and E වල current flow වෙන්න ඕනේ in the direction indicated by the arrowhead. You know the arrowhead is outwards, right? එහෙනම් මම මෙහෙම connect කරොත් හරිද කියලා ඔයගොල්ලන් බලලා කියන්න, right? මේක හරිද කියලා මට බලලා කියන්න. Give me 1 second. එතකන් මේක හරිද කියලා බලලා කියන්න. Quick. Okay, let me see. So wrong කියලා තියෙනවා, correct කියලා තියෙනවා. Okay. So according to the rules here, emitter collector වල කියන්නේ collector එකයි emitter එකයි අතරේ the current should flow in the direction indicated by the arrowhead, right? So if you look at this one, yes. Arrowhead එක තියෙන්නේ මෙහෙම. ඒ කියන්නේ මෙන්න මේ පැත්තට තමයි current එක යන්න ඕනේ. මෙන්න මේ පැත්තට තමයි හරිනම් current එක යන්න ඕනේ. හැබැයි මෙතන dry cell එක තියෙන විදිහ හරිනම් opposite current එක යන්න ඕනේ. එහෙනම් dry cell එකේ direction එක වැරදි, right? So the direction of the dry cell should not be like this. It should be to the other way round. මෙයා positive, මෙයා negative. බලන්න එතකොට හරියනවද කියලා. So this is positive, this is negative, no? You know in a circuit, current flows from the positive terminal to the negative terminal. In positive terminal එකේ ඉඳන් මෙහෙම ගිහිල්ලා negative terminal එකට current එක යනවා. මෙතන arrowhead එකත් ඒකටම ගානට match වෙනවා. So that means the dry cell should be connected like this. C should be connected to the positive terminal and E should be connected to the negative terminal. Did you all understand that? Give me a thumbs up if you all did. මම step by step අහන ළමයි මේක මුල ටික තේරුම් ගන්න ටිකක් අමාරුයි. That's why. Others, Sanuli, Sehasha, Situki, Kalna, Fatima. දැන් අනිත් අය අහනවා වගේ ඔයගලන්ටත් ප්‍රශ්න තියෙනවා නම් අහන්න. ඒවා හිතේ තියාගෙන ඉන්න එපා, right? හිතේ තියන් හිටියොත් you don't get the answers, no? Okay. ඔන්න එහෙනම් ඒක හරි. මෙන්න මේක හරි. Base collector ඊට කලින් මේක බලන්න emitter base junction should be forward bias. Emitter base. මේ තියෙන්නේ base එක මේ තියෙන්නේ emitter එක. Now this should be forward biased. In an NPN transistor base එක N semiconductor එකක්ද P semiconductor එකක්ද? Yes, base is a P semiconductor. Emitter? Is emitter a P semiconductor or an N semiconductor? N. Yes, N semiconductor. එහෙනම් ළමයි කොහොමද අපි forward bias කරන්නේ? It's very easy. Forward bias means P semiconductor එක positive එක්කෙනාට N semiconductor එක negative එක්කෙනාට. Positive to positive, negative to negative. එහෙනම් P semiconductor which is the base, I connect to the positive terminal. And N semiconductor which is the emitter, I connect to the negative terminal. ඔන්න එහෙනම් මම base emitter එකත් forward bias කරා. Alright. Let's come here again. Base collector junction should be reverse biased. ඒකත් අර වගේම තමයි ළමයි, right? Forward bias වෙන්න නම් positive to positive, negative to negative, no? You know මෙතන collect එකත් negative, right? So here positive to positive එක හරි. මේ පැත්තේ positive එක්කෙනෙකුට connect වෙලා. But negative to negative එක හරියන්නේ නැහැ. මොකද negative එක්කෙනා මෙතන positive එක්කෙනෙකුට connect වෙලා තියෙන්නේ. ඒක හින්දා base collector එක අතරේ even if you connect a wire there will not be a current flow. ඒ කියන්නේ අපි wire එකක් generally දාන්නේ නැහැ. සමහර වෙලාවට විතරක් දානවා but generally we don't put. This automatically is reverse biased. So no point. Reverse bias means there's no current. මේකට අපි කියනවා NPN. This is the NPN transistor. එහෙනම් ඊටු ටික හරියද කියලා බලමු. So C should be connected to a positive terminal. හරිනේ C connect ලා තියෙන positive terminal එකකට. E should be connected to negative terminal. E connect ලා තියෙන negative එකත් හරි. එතකොට බලන්න මෙතන this is the positive terminal, this is the negative terminal. So current flows like this. මෙතන මෙහෙම යනවා කියන්නේ මෙන්න මේ arrow head එක මෙහෙම තියෙනවා. So emitter එකෙන් එළියට එන විදිය තමයි current flow වෙන්නේ. Right? If you look at the small circuit, this is the positive terminal, this is the negative terminal. So the current flows like this. එතනත් current එක flow වෙන්නේ emitter එකෙන් එළියට එන විදියට. ඒ කියන්නේ circuits දෙකේම current flow direction එක same. හැබැයි මෙයාගේ voltage එක අඩුයි මෙයාගේ voltage එකට වඩා. So in order to explain this අපිට මෙන්න මෙහෙම පොඩි දෙයක් එකට ගන්න පුළුවන් something like this, right? Usually දැන් අපි ගත්තොත් එහෙම base එකයි emitter එකයි. So let's say NPN semiconductor එකක් ගත්තොත් this is P, this is N, this is, sorry, I got it wrong. This is N, this is P, and this is N. මේ තමයි base එක. මේ තමයි emitter එක. ඔයා collect එක අමතක කරොත්. This is the collector, no? If you completely forget the collector එක අමතක කරලා base එකයි emitter එකයි විතරක් බැලුවොත් this part is like a diode නේද ළමයි? Can you see that this part is like a diode? Yeah, because it's just PN, right? That's a diode. I have a question. Diode එකක් forward bias කරන්න කොච්චර voltage එකක් ඕනේද? In order to silicon වලින් හදපු diode එකක් forward bias කරන්න, what is the voltage that we want? Very good, Randira, Yansilu, Manisha, very good. Others? Anita, what do you all think? Not 0.3, that is for germanium. For silicon, in order to forward bias this, I need a voltage of, yes, correct, 0.7 volts. It can go to choti voltage, right? In both of these. Collector only considering base and emitter, it's kind of like a diode, right? And in order to forward bias a diode, you only need about 0.7 volts. එතකොට ළමයි මේ එලියස් සර්කිට් එකේ කරන්ට් එක තියෙනවානේ. එලියස් සර්කිට් එකේ කරන්ට් එක ඩිපෙන්ඩ් වෙන්නේ on this. You just have to give 0.7 volts to this. Here පොඩි 0.7 volts වගේ චූටි voltage එකක් විතරයි මෙතනට දෙන්නේ. මෙතනින් larger voltage එකක් automatically create වෙනවා. I mean let's say මම එක ආයි refresh කරා නම් අහගන්න. මෙතනට 0.7 volts වගේ චූටි voltage එකක් දෙන්න. ඒ චූටි voltage එකකින් චූටි current එකක් එනවා. right? ඒ current එක හින්දා ලොකු circuit එකේ ලොකු current එකක් හැදෙනවා. ඒ ලොකු current එක ඒ හැදෙන ලොකු current එකට match වෙන්න තමයි අපි මේකට ලොකු voltage එකක් දාන්නේ. හරිද? Did you get it? Let me explain it one more time. හොඳට අහගන්න. I think that will explain Yansilu's question a bit more, right? I voltages දෙක different කියන question එකනේ. මෙතන voltage එක පොඩිනේ මෙතන voltage එක ඒක ඇයි කියලානේ අහන්නේ. So that is a good question, right? So how I would explain this is that base emitter collector අමතක කරොත් only considering base emitter it's like a diode. PN විතරයිනේ තියෙන්නේ, so it's a diode. If this diode is made of silicon, you only need 0.7 volts to forward bias it. That is something that we already know. මෙයාට 0.7 volts දුන්නා නම් හොඳටම ඇති. 0.7 volts කියන්නේ it's a small current. ඉතින් මෙතන හැදෙන current එක හරියම පොඩි. Transistor එකක තියෙන වැඩේ තමයි මෙතන චූටි current එකක් හැදුනොත් ඒ current එක මෙතන automatically big current එකක් වෙනවා. ඒක අපි ඉස්සරහට කතා කරමු. We will talk about it more. But මෙතන චූටි current එකක් වා හැදුවොත් මෙතන එක ලොකු current එකක් විදිහට හැදෙනවා. ඒ ලොකු if a larger current is produced, ඒ large current එකට match වෙන්න voltage එක ලොකු වෙන්න ඕනේ. That is why we are connecting a larger voltage to the emitter collector circuit. Did you get it? Yansilu, did that answer your question? Okay. I think it will be more clearer when we are talking about the applications, but others, did you all understand this? කාට හරි තේරුම් නැති කට්ටිය ඉන්නවද? Okay, I will give you some time to draw these two transistors, because of course you have to. Okay. දැන් ඔයගොල්ලෝ මේ ටික මේ sentences ටික ඇඳගත්තානේ. now ඒකට යටින් PNP NPN කියලා මෙන්න මේ දෙන්නව ඇඳගෙන මම මේ ලියලා තියෙන ටිකත් එක්ක මාක් කරලා ලස්සනට ලියාගන්න. quickly. ලස්සනට ලියාගන්න, but don't take too much time, okay? Quickly. While you write this, give me a second. I'll give you 4 more minutes. Make Adiragamanu just think, right? Did I actually understand this? If not, you can ask me. Others done, no? I think my time, shall I close the timer? I think that is enough. Okay. All right. So Lamai, when we buy transistors in the textbook, I will not draw it on the whiteboard. All of you have the textbook, so turn to page 69 in grade 11 part 2. Page 69. In page 69, you can see how transistors actually look like, right? Then maybe there is a circuit එක ඇත්තටම ඉන්නේ ඕ වගේ. බාන ගොඩක් ඒවා බේස් එක තියෙන්නේ corner එකේ. Now the base is supposed to be at the middle, but in these transistors, in the real transistors, base එක corner එකේ තියෙන්නේ. හැබැයි ඇතුලේ තියෙන්නේ මේ විදිහටම තමයි. ඇතුලේ තියෙන්නේ මේ විදිහටම PNP මෙහෙම, NPN මෙහෙම, so there's no difference. එළියෙන් outward appearance එක විතරයි different වෙන්න පුළුවන්. ඒකත් the terminal, when you look at the terminals in these pictures, the base is always at the corner. But it's not always like that. Sometimes the base can also be in the middle. Different transistors are very different, right? And also, usually when we take transistors, transistors are identified based on like a code system. there's a code system. ඔගලන් ඒකත් ඒකෙම තියෙනවා. You can see 2SC828, 2SD400, 2SD313. So likewise, there are different codes that you can use to identify transistors. So අපි ඒක චුට්ටක් ඒ code එක විතරක් ලියමු because that is relevant to us. මේ sentence එක විතරක් ලියාගන්න ළමයි. To SC828. මේ codes read කරන්න ඔයගන්ට එන්නේ නැහැ definitely. Just MCQ එකගේ නිකමට හරි ආවොත් කියලා තමයි. But otherwise you don't need to know what these codes mean or anything like that. They are a bit more complicated. Quickly write this sentence. Okay, ළමයි. හරි. Now let's talk about the applications of transistors, right? මෙන්න මෙහෙමයි transistors වල applications යන්නේ. මේක ලියන්න එපා මොනවත් ලියන්න එපා. Keep your pen aside, just listen. Transistors mainly have two applications in our syllabus, right? එකක් තමයි transistors can be used as amplifiers for amplification. එනේ ඕනම එකක් වැඩි කරලා පෙන්වන්න. To increase the size or improve something. අනිත් එක තමයි switching action. Switching action. So under these, we are going to be talking about this, right? Amplification වල අපි බලනවා transistors can act like a current amplifier. Current amplifier. ඒ කියන්නේ චූටි current එකක් දුන්නොත් එයා ලොකු current එකක් produce කරනවා. Then this can be used as a signal amplifier too. Signal amplifier කියලා කියන්නේ ඔය චූටි signal එකක් දුන්නාම එයා ලොකු signal එකක් විදියට produce වෙනවා. Okay. Then switching action එකේ we can use a transistor as a switch. නිකන් switch එකක් විදියට use කරන්නත් පුළුවන්, and then we can also use it as a light dependent switch. ඒ කියන්නේ automatically light එකත් එක්ක වෙනස් වෙන switch එක. Light dependent switch. So basically we are talking about 4 applications, right? We are talking about how transistors can be used as a current amplifier, then how they can be used as a signal amplifier, how they can be used as a normal switch, or how we can use amplifiers as a light dependent switch. ඔය හතර තමයි අපි කතා කරන්නේ, right? So first of all, we will see how we can use the amplifier transistor as a current amplifier, right? So can we all put this, write this? Then you have like an overall idea. Make a tagga liyagan amplifying process. මේ දෙක ටග් ගාලා ලියාගෙන current amplifier කියන එක subtopic එකක් දාගන්න. Make it really fast, huh? With transistors within brackets put applications. Done. Okay. Others? Mama, what are your plans after O levels? Are y'all, I know that there are so many compared to back in our days. I mean, I did O levels not like very like 90s or O levels kare. But even then, like let's say since I've done O levels, it's been like 10-15 years. But compared to those days, now there are so many different paths that students take after O levels. And I especially see that because I have two younger sisters. So there's like a significant difference in how they go about with their future. So, what are your plans after O levels? You can let me know in the chat box. Like, are you all planning to do A levels? If you are planning to do A levels, what is the stream that you're doing? Is it biology? Is it maths or commerce or art, or there's tech now, right? There's tech stream. Or are you all planning to straight away go for a degree with a foundation course? What are your plans? Or are you planning to do like some other diploma? Okay, Ansilu, that's nice. So that means biological science, right? Bio. Others also, I would really like to know your plans because I'm just interested. I'm really interested because something that I notice is nowadays there are so many opportunities. But even back then, it was mostly like doctor, engineer, lawyer, and our ඒ වගේ හරිම mainstream ටිකක් තමයි හැමෝටම ගොඩක්ම like parents are insist කරන්නේ. But now it's so different because uh, I studied I did A levels in biological science and then I went to university in biological science and now I'm graduated. And my second sister, she went to a private university to study law. And my younger sister now she didn't do A levels, she did foundation and she's studying fashion design. It's interior designing, like so many like different and novel fields, like streams that you can study in. So Ekai Mama had me interested. I would like to know all of your plans. Hamogema. Now there are 19 of y'all. So okay. A level science in A level in physical science. Okay, good. Bioscience. Then maths. Okay, nice. Then going abroad, nice. Are y'all planning to study something specifically when you go abroad? Very good, right? After O levels, doing software engineering course and going abroad. Nice. Fashion design. Okay, nice. A level commerce. Did you have what is BBM? Lamai mehmai, wherever you go, there are opportunities, right? Mona de karat opportunities, trust me. And a lot of people tell you that in Sri Lanka, there are, I mean, it's good if you are going abroad, that's good because if you go to another country, there are so many more opportunities, more exposure. But nowadays in Sri Lanka also, there are so many opportunities. Don't let anybody tell you that Sri Lanka is a bad country to live or that there are no opportunities. The only thing is that Lanka education system that you are not actively seeking opportunities. Opportunities right? Especially now that there are so many like people going abroad, abroad and in the Lanka with opportunities right? And I decided to stay in Sri Lanka because now that I'm in this age of my life, I see so many opportunities and I'm like actively taking everything because Tarunakal, you have to try everything and you have to see what works, right? And something that I've noticed is that my partner sometimes is interviewing people in the offices. So a lot of them don't know how to face an interview. They have a lot of good knowledge because Sri Lankan universities, private or government, they're very good, right? Government so I went to University of Colombo. So very good. So godak Sri Lankan university system making Elliot and Lamai, Marma Honda knowledge but they don't have other skills, communication skills, and then like podi podi deva, like soft skills of leadership, project management. Yoga podi skills na. So they don't know how to face an interview. So evage podi podi deva right? So it's not always about knowledge. And whether you do, yes, there will be opportunities. Private university giyat, government university giyat, ලංකාවේ opportunities තියෙනවා. හැබැයි ඔයාව කොහොමද ගන්නෙ? How do you actively seek that opportunity? Whatever the opportunities are, that is a problem. So ගොඩක් වෙලාවට අපි ගත්තොත් එම බයෝක්‍රම හැමෝම හිතන්නේ ඩොක්ටර් විතරයි කියලා, right? But ඩොක්ටර්ට වඩා තව ගොඩාක් fields තියෙනවා. You have no idea. මම ඩොක්ටර් කියලා කියලා හිතාගෙන හිටියේ, but then when I went to the science faculty, University of Colombo, there are so many opportunities. It's even better than being a doctor. I'm not saying being a doctor is a bad thing, but even if you can't get there, there are so many other opportunities below that. Below that, not that it's below, but what I'm saying is, ඊට වඩා ලකුණු චුට්ටක් අඩු වුණාම අඩු වෙනවා. I mean, ගොඩක්ම ලකුණු තිබ්බොත්නේ medical faculty යන්න පුළුවන්. That's why. So for that question, for commerce stream, there's a lot of competition. That is true. Commerce and arts වල competition ගොඩක් වැඩි because there are so many students doing it, right? ඒක හින්දා you'll have to work extra hard. එතකොට when you go to university, after university, I suppose that there will be so many opportunities, right? In Sri Lanka, there will be so many opportunities. Even if you decide to go abroad, again, there will be many opportunities. I don't think doing A-levels is a waste of time. Mama කියන්නේ මේකයි ළමයි, something that I tell my sisters as well. ඔගොල්ලන් කරන ඔගන්ට life එකේ යන්න ඕනේ path එක අනුව තමයි ඔගලන් A-levels කරන එක waste of time ද it's the best way to spend your time ද කියලා decide when. For an example, let's say you want to become a doctor, or you want to become a vet, or like a dentist, or like let's say science field එකේ ගිහිල්ලා scientist කෙනෙක්, researcher කෙනෙක්. ඒ ගොඩක් තියෙනවා science වල ඒවා. ඔයගලන්ට ඒව ගැන details ඕන නම් ඒ වගේ දේවල් අහන්න ඕන නම් you can let like ask me on WhatsApp. I will let you guys know because මේ මුළු වෙලාවම ගන්න බැරි හින්දා. But ඒ වගේ පැත්තෙන් යන්න ඕන, of course it's obviously better to do A levels, right? A levels කරන්න ඕන. මොකද A levels වල ඒකට හරියන පාරක් කැපිලා තියෙනවා. If you want to do engineering, or if you want to do mathematics or physical science, data scientist, ඒ වගේ දේවල් කරන්න ඕන, you have to most probably do maths. So ඒකට හරියන path එකකුත් කැපිලා තියෙනවා. Commerce වල තමයි, arts වල තමයි. But now for an example, let's take a very niche stream like fashion design කියලා අපි ගමු. Fashion design වලට A levels වලින් යන්න පුළුවන් path එක ටිකක් අඩුයි. I mean arts කරලා arts වලින් එහෙම යන්න පුළුවන්. But ඒක අර it's not a very refined path. So ඒ වගේ නම් you can decide to go to a private university. ඒතර බලන්න ඕනේ, is it worth your money? Because to go to a private university to do foundation course and then like proceed with like 3 or 4 years, it takes a lot of money, right? So is it really worth it? මේකද මට කරන්න ඕනේ, මේ සල්ලි ටික මම වේදන් කළා, මේක කරාට කමක් නැහැ. Right? So choose wisely whatever you are doing. ඒකින්ද A levels කරන එක generally අපිට කියන්න බෑ A levels කරන එක waste of time කියලා. ඔයාට කරන්න ඕනේ දේ අනුව තමයි you have to decide, right? So as I said, my younger sister, she's doing fashion design, so that's why A levels වලින් එකට හරියට path එක කැපිලා නැති හින්දා she decided to go to a private uni, and her best friend is doing interior designing, again the same story. So එහෙම තියෙනවා, right? So that really depends. A level in commerce stream, good. Then Australia, okay, good. Then bio in A levels, good. I wonder where you guys will be in another few years. You like physiology? Nice, very nice. Kwanit kattege monada balamu. A level in science, A level in maths, then interior designing, very good, nice. All of you have very good plans, no? Medical faculty, but of course you can go abroad, right? But මෙහෙමයි ලංකාව යන්න පුළුවන් නම් would be good. I think you can try because abroad යනවා කියන්නේ imagine the amount of money. But ලංකාව යන්න try එකක් දෙන්න බැරි නොත් you can go abroad. Really again depends on what your preference is. Languages, because I'm quite good at learning new languages and also hope to do a job where my language knowledge can be of use. Okay, nice, good. A level in tech, okay. කොහෙතර අනෙක් කට්ටිය like to be a lecturer. Okay, that's nice. That was, or I think is also my plan, to do a lecturer, to do lecturing, to be a lecturer. Okay, so that is very exciting. I wonder where you guys will be in another 10-15 years. 10 years wage එක එක තැන්වල ඉඳිනේ. So now you guys are 15, 16. So in another 10 years, you will be 26. That is my age now. Yeah, okay, we'll see. So anyhow, whatever you do, හැම වෙලෙම හොඳට හිතලා බලන්න, right? හොඳට හිතන්න. If you want any professional help, ඒකට අදාළ කාටකරි කතා කරන්න. Something that I did after A levels was that මම ගොඩාක් කට්ටියත් කතා කරේ දන්න කට්ටියත් එක්ක ඔය අපේ ගෙදර ළඟ හිටියා lecturer කෙනෙක්. He was a lecturer in Colombo University. So එයාත් එක්ක කතා කරා, තව කීප දෙනෙක් එක්ක කතා කරා. So ඒ lecturer එක්ක කතා කරලා තමයි මට හිතුනේ okay, so this is what I want to do. I want to go to government uni and then I'm going to do this that. Then my plans changed. I mean I got graduated and all that, but I'm still like a path එකත් මම යනවා. I'm a researcher, but at the same time I'm doing other things in life as well. So life is kind of fun and nice. What an opportunities ඔක්කොම අරගෙන මොනවාද what you want to do in life කියලා හරියට decide කරලා කරන්න ඕනේ. Again, as I said, you guys have a lot of different paths to take. So something that I personally believe in and something that I advise my students to is that සමහර අය මගේ students O levels කරලා A levels කරාට පස්සේ they come and talk to me and they're like, what should I do? And what I say is හැමෝම මෙයා කරනවා කියලා ඔයා කරන්න ඕනෙත් නැහැ. Right? මේකට තමයි these are the highest paying jobs කියලා කියන doctor, engineer, lawyer, ඔයගේ හරි mainstream jobs ටිකක් තියෙනවානේ. ඒ ටිකම මම කරන්න ඕනේ කියලා එකකුත් නැහැ. When you're choosing the path that you want to take, you have to know that මේක තමයි මම මගේ life එකට කරන career එක. This is how I'm going to earn. This is what I'm going to do in my life. Right? එතකොට every day you wake up and what is අපෝ මම අදත් වැඩට යන්න ඕනේ එහෙම කියලා හිතනොත් එම එතන එක අපරාධ, right? Every day you're living in like අයෝ හැමදාම යන්න ඕනේ කවදාද නිවාඩු. I mean all of us are going to do a job at some point, right? But උදේ හැරෙද්දී you're like, if you're excited to go to work, do what you love, right? So that is nice. එතකොට හැම වෙලේම something that makes you happy is something that you should do, because that is what you will be doing for the rest of your life, right? එතකොට now let me tell you one more story before we proceed. One of my students wanted to do psychology and become like therapist, counselor, or a psychotherapist. So ඒ දවස්වල පොඩි මේකක් තිබ්බා, like psychology කියන්නේ එච්චරම හම්බ කරන්න පුළුවන් එකක් නෙවෙයි එහෙම කියලා. ඊට පස්සේ like ඒක ගැන හොයලා බැලුවාම I mean ඒ student තාම පොඩි ඉතින් she's still not a psychotherapist, but ඒක කියන්නේ නිකන් හොයලා බැලුවාම we found out that there are actually so many opportunities, right? ගොඩක් ඒවා අපි දන්නේ නැහැ, මිනිස්සු දන්නේ නැහැ, that's why. So yeah, දැනට O level focus කරන්න, but at the back of your head you should have some plan, no? So I'm very happy to listen to your plans, right? So many diverse plans. That's very nice. Going abroad or staying in Sri Lanka or doing A levels or not doing A levels or whatever it is, it's very nice. And අනිත් එක තමයි ගොඩක් වෙලාවට දැන් yes, you have to think wisely and take decisions, but also don't stress out and overthink and get anxious about your future, because ඔයා දැන් මේ වෙලේ අම්මලා තාත්තලා එක හැමෝටම කතා කරලා ගොඩාක් randomly නැන්දයි මාමයි පුංචි බාප්පා හැමෝත් එක්කම කතා කරන්න යන්න එපා. මේකට ගැලපෙන ඔයාගේ decision එකට ගැලපෙන අයත් එක්ක. Obviously you have to talk to your parents. Then ඔයාට let's say if you want to do software engineering, ඔයා දන්න කවුරු software engineers ඉන්නවද? What do they say about it? ඒව චුට්ටක් හොයලා බලලා decide your path. මොකද සමහර වෙලාවට ඔයා select කරන path එක නෙමෙයි මැදදී ඔයගොල්ලෝ වෙන path එකකට වැටෙන්නත් පුළුවන්. That is how life is, right? But yeah, it was nice listening to your plans. Okay. So අනිත් එක තමයි තව චූටි දෙයක් ළමෙක් මගේ අහලා තිබ්බා ඔයගලන්ගේ grade එකේ what you should, I mean after O levels you have this little vacation period before A levels start. A level classes නම් O levels ඉවරච්ච ගමන් මම හිතන්නේ පටන් ගන්නවා. හැබැයි A level school පටන් ගන්න කලින් චූටි vacation එකක් තියෙනවානේ. ඒ කාලේ මොනවද කරන්න පුළුවන් දේවල් කියලා. Right? Something that like will help you in the future. So මම ඒක ගැන ඔයගලන්ට මේ Saturday Sunday classes වල කියන්නේ දැන් අද අපි ගොඩක් extra දේවල් කතා කරානේ. We talked about like your future plans and all that. So in another day I will tell you what you guys can do after O levels when you have that little vacation period. Of course you guys can have fun, But at the same time, choti දේවල් තියෙනවා ඒවට time invest කරලා ඔයාලා learn කරොත් it will be very useful for you in the future. So එක student කෙනෙක් අහපු ප්‍රශ්නයක් and I will tell you guys more about that later. Okay, so current amplifier, right? මේකට first of all we will draw this circuit, right? මේ circuit එක මම draw කරන්නේ නැහැ. No, I will draw actually. Textbook එකේ තියෙන diagram එක චුට්ටක් not very clear. Then lamai, we learned that there are PNP transistors and NPN transistors. In your syllabus, we are only going to be talking about applications relevant to NPN transistor. We are not going to be talking much about PNP transistor. May discuss කරපු ටික දැනගත්තාම ඇති PNP ගැන. හැබැයි එතනින් එහාට අපි කතා කරන්නේ NPN transistor එක ගැන, right? So, this is my NPN transistor. So as usual, we have the base here, and we have the collector here, and we have the emitter here. And you know the arrowhead goes out of the emitter, right? So, here I'm going to connect a bulb. Bulb එකක් circuit එකක අඳින්නේ මෙන්න මෙහෙම, right? I'm going to collect a bulb here. And then මේ circuit එක මම complete කරනවා. For this, I'm going to connect some dry cells. 2 dry cells. Like this. On the other hand, මේ පැත්තෙන් මම complete කරනවා. මම මේකට connect කරනවා another bulb here. And මෙතන මම variable resistor එකක් connect කරනවා. I will explain all of this later. And here, I forgot to draw one thing here. We need the switch here. මාත් එක්කම draw කරගත්තත් හොඳයි. ඔයගොල්ලන් current amplifier කියලා subtopic එක දැම්මනේ මාත් එක්ක මුලින්ම setup එක draw කරමු. Then we can discuss the rest later. Yeah, there's another switch, and then there's another dry cell, set of dry cells like this. Don't miss any element. හොඳට බලලා draw all the components properly. We'll mark some of these. This is bulb L1. This is bulb L2. Switch S1. Switch S2. This is VR. I will explain the diagram and all the components later. First of all, draw this. Yes, sure, anytime. Like if you have any question regarding what you're going to do after O-levels, or if you want to like, even if I can't answer some of the questions, like let's say you want to do commerce and you want to see how that stream is, you can let me know. Like I can ask somebody and let you know, because I have so many friends who did commerce and who are like now in the job industry doing jobs and all that. So yes, ඔගන්ට ඕනම දෙයක් තියෙනවා නම් not just subject relevant ඔගලන් after O levels මොනවද කරන්නේ, what are the good things to do, or if you have no idea at all and you want to just talk or anything like that, you can let me know, of course, anytime. A few students had a concern about the class time, so අපේ කියන usual class time එකට තමයි stick වෙන්නේ 7:30 to 10. So yeah. Meg Andala, I will be writing a few sentences underneath. Also write these few sentences. Huh? I will give you 4 more minutes to complete this and write the 2 sentences that I wrote. Make it fast. Let me 2 more minutes. I think that's enough time, no? So some of you are done. Okay. මේ time එක ඕන නැහැ නේද? එහෙනම් ළම මෙච්චර time එක මම වැඩි time එක තිබ්බා. Can you give me a thumbs up if you have finished? Ashwini, Batula, Binuti, Dinugi, Disal, Fatima, Imasha, Kalna, Manisha, Mikeli, Unioke, Nuda, Moneli, Andira, Sanuli, Sehasha, Senet, Setamini answered. Okay. All right. Now I will explain what exactly happens. අපි මුලින්ම මේ different components ගැන discuss කරලා ඉමු. Let's talk about this VR. VR is actually a volume controller. Right? Volume control එකක් කියන්නේ variable resistor එකක්. Now do you all remember what a variable resistor is? What is a variable resistor? What do you remember about variable resistor? What exactly do you remember about a variable resistor, which we learned in grade 10 under types of resistors? Apko fixed value resistor තියෙනවා, variable resistor තියෙනවා, light dependent resistor තියෙනවා. So what is a variable resistor? In very simple terms. Yes, correct. Others? Others? Yes. Yes, Lama. Variable resistor the resistor is not a fixed value. You can always change it. You can change it. Like we can manually change the resistance, right? මේකත් එහෙම එකක්. වෙන්න මේකත් එහෙම එකක්. මෙතන වෙන්නේ මෙන්න මෙහෙම එකක්, right? Now, if you look at this one, කොහොමද තියෙන්නේ? Now here we can adjust it. Now let's say මට මේ arrow head එක මෙන්න මේ හරියට වගේ adjust කරන්න පුළුවන්. Right? In another situation, I can also do something like this. මට මෙයා මෙහෙම උඩටම ගිහලා adjust කරන්නත් පුළුවන් like this. මෙහෙම adjust කරන්නත් පුළුවන්. Like this arrowhead I can move back and forth in the resistor to adjust, right? එතකොට මොකද වෙන්නේ? now මෙතන battery එක තියෙන මෙහෙමනේ. So battery එක මෙහෙම තියෙනවා කියන්නේ so the battery is connected like this. මම මුළු ඔක්කොම අඳින්නේ නැහැ. I'm only drawing that particular part only, right? So let's see how current is going here. Positive terminal එකේ නම් මෙහෙම current එක එනවා. ඇවිල්ලා මෙතනට ඇවිල්ලා මේ මුළු resistor එක throughම යාට යන්න වෙනවා. මේ මුළු එක throughම current එකට යන්න වෙනවා. And then මෙතනට එනවා ඔහොම තමයි යන්නේ. If you look at this instance, so this is the positive terminal no, so current එක මෙහෙම යනවා. මෙහෙම යනවා and then මේ මුළු එක through යාට යන්න ඕනේ නැහැ because it's connected here no. and යාට මෙන්න මේ ටික ගියාම ඇති. So if I consider that this is, let's say, circuit A and this is circuit B, which one has a higher resistance, A or B? A to the resistance body, B to the?
8.
Batula says A, Kalna says A, Yansilu says A, Muni says A, Randira says A. What about others? Anybody is saying B? Correct lamai ege thamai resistance එක වැඩි because current එක මෙහෙම ගිහිල්ලා එයාට මේ මුළු resistor එක through ම යන්න ඕනේ. That means අගේ resistor එක වැඩි. Resistance වැඩි. But if you take B යන්න තියෙන මෙහෙම ගිහිල්ලා මෙතනට ආවා අර resistor මුළු එකම through යන්න ඕනේ. It can just go like this. So that is how this using the arrowhead you can change the position. Depending on the position, the resistance can be altered or the resistance can be different. හරිද? ඒකට තමයි මෙන්න මේ variable resistor එක තියෙන්නේ. මේ variable resistor එකට අපි use කරන්නේ volume control එකක්. You know, in the cars or in radios අර මෙහෙම රවුමට කරකවන volume controllers තියන්නේ. ඒකෙත් වෙන්නේ එහෙමයි. මෙන්න මේ පැත්තටම කරකවද්දී resistance එක අඩු වෙනවා. අඩු වුණාම current එක වැඩි ඒකින්ද high-යෙන් සද්ද යනවා. When you rotate it to the other end, resistance එක හොඳටම අඩුයි. resistance එක හොඳටම වැඩි. ඒ කියන්නේ current එක හොඳටම අඩුයි. current එක අඩු හින්දා you hear the sound, you don't hear the sound properly. Right? Again, සද්ද හොඳටම අඩුයි. Right? So that is a volume controller. So variable volume controller is a variable resistor. දැන් මෙතන අපි මුලින්ම මෙහෙමයි කරන්නේ. Listen very carefully. I'm going to close switch S1. S1 එක close කරනවා. Close කියන්නේ on නේ. If I draw roughly a table like this, මම S1 එක on කරනවා. Okay. Okay, I switch S1 on, right? S1 එක on කරලා මම මොකද කරන්නේ? මම volume control එක adjust කරනවා එහාට මෙහාට. Volume control එක එහාට මෙහාට adjust කරනවා until the L1 lights up. L1 bulb එක light වෙනකම් මම volume control එක එහාට මෙහාට adjust කරනවා. Adjust කරලා at some point I will see that the bulb is lighting up. Bulb එක light වෙන තැනදීම මම ටක් ගාලා volume control එක කියන්නේ variable resistor එක stop කරනවා. Right? So that is where the bulb lights up. Then මම S1 එක ආයමත් close කරනවා. Sorry, or open කරනවා. So that is it's off, right? It's off. ඊට පස්සේ now I adjusted my volume controller or my variable resistor in such a way that there will be a current flow enough to light up the bulb. L1. L1 ව light up කරන්න පුළුවන් තරම් resistance එකක් එනකම් මම variable resistor එක adjust කරලා ආයමත් S1 එක off කරනවා. Right? ඊළඟට මම මෙන්න මෙහෙම දේවල් ටිකක් තමයි බලන්නේ. Right? What I'm going to check is S1 switch එකයි S2 switch එකයි off on කර කර මම බලනවා කොහොමද lights off on වෙන්නේ off වෙන්නේ ඒ ටික තමයි මම බලන්න යන්නේ. Right? So may S1, then S2, then L1 and L2. Okay. My table is not very nice. දැන් ඔයගොල්ලෝ මොනවද අඳින්න එපා. First only listen. Then I will give you time to draw this table, right? Give me a second until I complete the table. Okay. So this is my S1 switch and this is my S2 switch, right? Then I'm going to observe the L1 bulb and the L2 bulb. හරිද? ඔන්න දැන් හොඳට බලා ගන්න, right? මෙන්න මේවා තමයි එන observations. First of all, I'm going to on S1. No, මුලින්ම මම S1 එක off. Off කියන්නේ මෙයා මෙන්න මේ විදිහට open කරලා S2 එකත් open කරලා. Open means off, no? So, මෙයාත් off. මෙයාත් off. And then I'm open. Then I look at L1 and I can see that L1 does not light up. L1 එක light up වෙන්නෙත් නැහැ, L2 එක light up වෙන්නෙත් නැහැ. මොකද switches දෙකම off වෙලානේ. So, L1 does not light up. Does not light up. L2 also does not light up. Then මම මොකද කරන්නේ? I'm going to on S1. ඒ කියන්නේ I'm going to close. මේක close වෙනවා කියන්නේ මෙයා on වෙනවා. So I'm going to on S1 but S2 off. S2 මම on කරන්නේ S2 off, S1 විතරයි on. S1 on and S2 off. I'm going to look at the two bulbs, right? මම bulbs දෙක දිහා බැලුවාම this is what I can see. L1 lights up. L1 bulb එක පත්තු වෙනවා. හරිද? හැබැයි brightness එක අඩුයි. Low brightness එකකින් තමයි යා පත්තු වෙන්නේ. Okay. So L1 කියන bulb එක light up වෙනවා. But less brightness. Now S2 switch is off no. ඒකින්ද L2 light වෙන්නේ නැහැ. L2 light වෙන්නේ නැහැ. That is my second situation, right? Now let's look at the third situation. Third එකේ මම S1 off කරලා S2 on කරනවා. So S1 is off. S1 is off, but S2 is on. What do you think about L1? Will L1 light up? Now මෙතන S1 is off, S2 is on, na? L1 light up වෙනවද? Okay, others? No, L1 will not light up. Yes, L1 will not light up. What do you think about L2? What do you think about L2? Some say yes, some say no. Actually, Lamai, a very important observation that we make here is that the S2 closed. S2 closed means it's on. No? So if this is on, L2 should light up. No? But in reality, L2 will not light up. At the katandare, L2 light up in there. May switch on karla tibbat may light up in there. Right. Okay, we will see about it. But let's go to the second one. Then nama on karna. S1 on, S2 on. S1 on, S2 on. So then you can see that L1 bulb will light up. I can see L2 bulb also lights up. But L1 will light up, L2 will light up වෙනවා. මෙයාගේ brightness එක අඩුයි. L2 will have a high brightness. මේක තමයි අපිට එන observations ටික. From this, what can you say about this circuit? මට ඔයගන්ට හිතෙන මොනවද මේකේ observations? Can you tell me one of the observations that you think? I got one correct answer. What about others? බාන ළමයි දෙන්නම off නම් මේ දෙන්නම light up වෙන්නේ නැහැ. That makes sense no? දෙන්නම off දෙන්නම light up වෙන්නේ නැහැ. මෙයා on වෙලා තියෙදි මෙයා light up වෙනවා. Because මෙයා on means මෙතනින් current එකක් යනවා. So because of this current L1 will light up. හැබැයි මෙයා off හින්දා L2 light up වෙන්නේ නැහැ. That also makes sense. ඊට පස්සේ බලන්න third එක. Third එක is what actually doesn't make sense. Why? L1 off, sorry, S1 off. S1 off in the L1 pathway, that makes sense. But S2 is on, S2 on to not L2 light වෙන්නේ. That means මෙතන current එකක් නැත්තම් මෙතනත් current එකක් නැහැ. මෙයා on වෙලා තිබ්බට වැඩක් නැහැ. මෙයා on වෙලා තිබ්බත් if there is no current here, there will not be any current here. Yes, current flows only when a current flows in the input circuit. Yes, correct. So that means අපේ පොඩි circuit එකේ current එකක් තිබ්බොත් විතරයි ලොකු circuit එකේ current එකක් තියෙන්නේ. මේ switch එක on කරලා තිබ්බත් doesn't matter. Now, you would think if S2 is on, L2 should light up. But L2 doesn't light up. Why? Because there is no current in the smaller circuit. Okay. And in the last one, okay, now both the switches are on. Eka hinda, both the light bulbs will light up. Both the bulbs will light up. You can see මෙයාගේ brightness එක අඩුයි, මෙයාගේ brightness එක වැඩි. Right? So ළමයි, let me introduce some terms. අපිට terms ටිකක් කියන හොඳට අහගන්න. Now, when both the switches are on, there will be a current going through this circuit. No? A current එකට අපි කියනවා IB කියලා. Then when this is on, there will be a current flow in this circuit as well. එහෙම current flow එකකුත් යනවානේ. In the out circuit, the big circuit. මේ current එකට අපි කියනවා IC කියලා. Right? Actually, IB means base current. And IC, we call it collector current. Those are just two names. මේ පොඩි එකේ යන current එකට we call it IB base current. ලොකු එකේ යන එකට අපි කියනවා IC, that is collector current. Emitter current කියලා එකක් නැහැ because emitter is actually common to this and this both නේ. මේ emitter එක දෙකටම common නේ. So therefore there's nothing called emitter current, right? And also another thing is that we call this small circuit the input circuit. And we call this big circuit the output circuit. These are some terms. Now, from these observations, what we can understand is current flows in the output circuit only if there's a current in the input circuit. Input circuit එකේ current එකක් තිබ්බොත් විතරයි output circuit එකේ current එකක් තියෙන්නේ. Right? Input circuit එකේ current එකක් නැත්නම් මේ switch එක on වෙලා තිබ්බත් output circuit එකේ there won't be a current. Right? ඒකෙන් අපිට කියන්නේ the output circuit current, that means IC, depends on the input circuit current, which is IB. මොකද මෙයා නැත්තම් මෙයක් නැහැ. So IC depends on IB. Then, if there is a current in the input circuit, which is IB, there will be a current in the output circuit, which is IC. But here, this will have a less brightness and this will have a high brightness. Less brightness and high brightness, what can you say about the current? Less brightness means less current, no? High brightness means high current. Right? Did you all understand this one? Before we write the points, did you understand this one? Everybody, I need to know everybody's opinion. Did you all understand this? Definitely, Pamodi, I will send the recording. It's okay. I understand. I will send the recording. Yes. Anybody who has any questions? හැමෝම කිව්වද තේරුණාද නැද්ද කියලා? හරි. මෙන්න මේක චුට්ටක් ඇඳ ගන්නත් ඕනේ. Volume control එක නැත්නම් ඔයගොල්ලෝ දන්නේ නැහනේ, right? So ඒක මම side එකේ මෙහෙම complete කරනවා. Give me 1 second. Don't write anything yet. මේ volume control එකක් which is a variable resistor. එකයි VR කියලා යට දාන්නේ. VR කියලා දාන්නේ because it's a variable resistor. VR. So you can see here resistance is high, here resistance is low. So that is how we determine the current, right? Resistance එක වැඩි කියන්නේ disturbance එක වැඩි. ඒතකොට current එක අඩුයි. Make it resistance අඩුයි. Therefore disturbance අඩුයි. Current එක වැඩි. ඒක අපි ඉස්සර discuss කරපු එක, right? So මෙන්න මේ volume control එකත් side එකකින් ඇඳ ගන්න. මේ table එක ඉක්මනට ඇඳ ගන්න ළමයි. Then I have a few points to write. මේ volume control එකයි table එකයි ඇඳ ගන්න. I will give you 4 minutes. 5 minutes. Make it fast. While you write this, give me a minute. Huh? Done writing? One of you is done. Lamai, have you all finished? Give me a thumbs up, please. If you all have finished. All right. What about others? Okay. Now we will write this, right? We can save time, right? 1 second. Yeah. So this is actually why Lamai we call that a transistor can be used as a current amplifier because it amplifies the current. මෙතන brightness එක අඩුයි කියන්නේ current එක අඩුයි. මෙතන brightness එක වැඩි කියන්නේ current එක වැඩි. ඒ කියන්නේ input circuit එකේ current එකක් ගියත් small current එකක් අපි දුන්නොත් that will be amplified or increased as a larger current in the output circuit. That is why we say it can be used as a current amplifier. Amplification. Quickly write. Let me know when you're done. Okay. Manisha done. Muni done. Vinuti done. Yansiru done. Ashwini done. Himasha Seneth done. Okay, I think we can move on. What about others? Batula, Dinugi, Disal, Fatima, Micheli, Khalna, Nudam, Unili, Randira. No, okay. I'll give you 1 more minute. If you have any questions in the current amplification process, let me know. It's really not that difficult. Transistors get overthink කරන්න එපා. Overthink කරන්න එපා. කොහොමද transistor එක ඇතුලේ වැඩ කරන්නේ? Because actually you will learn this at some point in life, but O levels is definitely too young for you to learn that. Inside a transistor, how does it work? I make a වැඩි වෙන්නේ. So don't worry too much, right? එමුත් ඔක්කොම පැටලෙනවා. So what you need to understand is that, of course, there has to be a base current, or there has to be a current in the input circuit for a current to be in the output circuit, which is the collector current. Input circuit එකේ current එකක් නැත්නම් output circuit එක කොහොම තිබ්බත් වැඩක් නැහැ. There will not be a current. And most importantly, when there's an input current, there will be an output current, and the output current or the collector current IC will be significantly larger than the input current, which is IB, right? ඒකයි අපි කියන්නේ මේක current amplification වල use කරන්න පුළුවන්. Amplification means increasing, right? Okay, put the next අපි current amplifier subtopic එකනේ දැම්මේ. So අපේ applications වල we finished current amplifier. Now we will talk about signal amplifier. Put a subtopic. Signal amplifier. Again, here also, before we discuss, we will first draw, right? Draw කරලා discuss කරමු නැත්නම් discuss කරන්න අමාරුයිනේ. So as usual, we need a transistor like this, which in your syllabus, we are only talking about NPN transistors and their applications. So here we have the base, here we have the collector. And here we have the emitter. Mid circuit, this is the same circuit as what's on the textbook. If you all want to, textbook in Balanga. Here I'm gonna connect a loudspeaker. Give me 1 second, Lamai. එහෙනම් අපි AB නැතුව we will put xy. Otherwise base එකේ B එකත් එක්ක පැටලෙනවානේ. I will explain all of these components later. කියන මුලින්ම ඇඳ ගන්න. Yeah, this is the diagram. Quickly draw this diagram, then I will explain. Quickly, let me know when you're done. Okay. Okay. Everybody done, right? Who needs more time? Okay, I'll give you 1 minute, 1 or 2 more minutes. Make it fast. Okay. So this is how we can use a transistor to amplify a signal. Now we are amplifying a signal. So separately, right? First of all, this 22 kilo ohm resistor here. 22 kilo ohms is a lot of resistance, right? So 22 kilo ohm would be 22,000 ohms, in other words, right? 22 kilo ohm. Can it 22,000 ohms? A kilo means 1,000. So 22 kilo ohms is 22,000 ohms, right? That is a lot of resistance. That is a large resistance, right? Then usually base එකයි collector එකයි අපි connect කරන්නේ නැහැනේ, right? We usually don't normally අපේ තියන්නේ මේ විදියට. But now here it's different. I will tell you why, right? If you remember at the very initial part of transistors, we talked about the rules of how to bias a transistor. We said that emitter collector අතරේ current එක යන්න ඕනේ current එක යන්න ඕනේ arrow head එක තියෙන පැත්තට. So ඒක නම් හරි because this is the positive terminal. So positive to negative තමයි current එක යන්නේ. ඒ පැත්තටම තමයි arrow head එක තියෙන්නේ. So that is no problem. Then we also know base and emitter. Base එක emitter එක, it should be forward biased, right? If you look at the previous circuit, base, you know, base is P. P is connected to the positive terminal. It is N and it is connected to the negative terminal. So it is forward biased, no problem. Now look at this. Method base emitter but is there a dry cell? 1 or 2 dry cells. Is there dry cells here? Or is there any power source? Dry cells nata වෙන මොකක් හරි power source එකක් හරි තියනවද base එකයි emitter එකයි අතරේ? No. ඉතින් දැන් ඒතර කොහොමද අපි base එකයි emitter එකයි forward bias කරන්නේ? Because a transistor will not work otherwise. In order for us to... Am I still lagging? Am I still lagging? Hamodi, might be a connection issue from your end. Do you still... No. Hamodi, can you hear me? Is it still lagging? Okay. Okay. Try to move up. All right. Okay. So, yes. If the base emitter junction is not forward biased, the transistor will not work. Then we make a forward bias power source. Look at this very carefully. Yeah? I will use a different color to show this. You know this is an NPN transistor. So base is a P semiconductor and emitter is an N semiconductor. Emitter එක මෙතන මේ negative එකට connect වෙලා ඉන්නේ කොහමද? Right, emitter එක negative එකකට connect වෙලා ඉන්නේ. මොකද මෙතන negative එකක් තියෙනවානේ. So emitter A negative terminal එකට connect වෙලා ඉන්නේ. So emitter is N-type semiconductor and it is connected to a negative terminal. So මෙතන negative තියෙනවා කියන්නේ මෙතනක් තියෙන්නේ මෙන්න මේකනේ මෙතන. So this is also negative. So emitter is anyways connected to a negative terminal. Emitter is N-type semiconductor and it is connected to a negative terminal here. Base is P-type semiconductor. Then බලන්න මෙතන මෙහෙම wire එකක් තියෙන හින්දා මේ base එක මෙහෙම ගිහලා මෙතනට connect වෙලා නේද ඉන්නේ. And this is positive. Base is a P-type semiconductor and it is connected to the positive terminal. මෙතන නැති වුණත් මෙතන හරිය තියෙනවානේ. Somewhere it is connected to a positive terminal. Emitter is connected to a negative terminal. So positive to positive, negative to negative, it became forward biased. Did you all understand that? Did you all understand that, Lamai? Let me explain that one more time. Okay, I will explain it one more time. හොඳට අහගන්න. Base emitter junction should be forward biased, right? Forward bias කියන්නේ මොකක්ද? මෙහෙම N should be connected to a negative terminal. Now, this is N, no? මෙයා N. Emitter is N. You can see here N is connected to a negative terminal here. So that is all okay. Base is P now. And you can see P is connected to a positive terminal here. එහෙනම් positive to positive, negative to negative, the BE junction became forward biased because of that. ඒකයි අපි අතර මෙහෙම branch එකක් දාලා තියෙන්නේ මෙතන. මෙන්න මේ කොටස දාලා තියෙන this part is drawn here because of that only. මොකද මෙතන power source එකක් නැහැනේ. Base emitter forward bias කරන්න නේද? That is why. Yes, Yansilu. Current flows through the loudspeaker. I will explain how it happens, right? So now base emitter is forward bias, no problem. Now there's a small problem. Right? Forward bias katandare hare. දැන් මෙතන this is forward bias now. This is forward bias now. ඒක හරි. Now we have another problem. Let's see what this is. මොකක්ද දන්නවද අනිත් ප්‍රශ්නේ? Let me first erase this part. Okay. අනිත් ප්‍රශ්න ළමයි. හිතන්න මෙයාගේ voltage එක 3 volts කියලා. So let's say positive, this is 3 volts. The voltage is 3 volts. You can see base is connected to the positive terminal, emitter is connected to the negative terminal. ඒකින්ද base එකයි emitter එකයි අතර තියෙන voltage එක 3 volts. Why? Because base is connected to this dry cell, emitter is also connected to this set of dry cells. So එතන voltage එක 3 volts කියන්නේ මේ දෙන අතරේ voltage එක 3 volts. Right? Now I will use a different color. Collector is also connected to this positive terminal. Again, emitter is connected to this negative terminal. Emitter එකයි collector එකයි අතරේ තියෙන්නේ 3 volts නේද ළමයි? Do you all understand that? The same amount of current flows through emitter collector and also base emitter. එකම current flow එක තමයි යන්නේ. ඒක තේරුණාද ඔයගලන්ට? Nudam, Imasha, Dinugi. No. Okay, I will explain it again. මෙහෙම. අපි ගත්තොත් මෙතන emitter එක connect වෙලා තියෙන්නේ මෙයාගේ negative terminal එකට, base එක connect වෙලා තියෙන්නේ එයාගේ positive terminal එකට. Right? At the same time here, collector is also connected to the positive terminal. මෙතන emitter එක connect වෙලා තියෙන්නේ negative terminal එකට. එතකොට emitter collector එකේ voltage එකමයි නේද base emitter එකටත් එන්නේ. I'm sorry, it got erased. මම මේ highlight එකකින් පෙන්නන්නම්. Emitter is connected to this negative terminal. මේ negative terminal එකට base එක connect වෙලා තියෙන්නේ මේ positive terminal එකට. ඒ වගේම emitter is of course connected to the same negative terminal. Collect එක connect වෙලා තින්නේ තව positive terminal එකටම තමයි. එතන collect එකයි emitter එකයි අතරේ voltage එක ගත්තත් base එකයි emitter එකයි අතරේ voltage එක ගත්තත් both the voltages are the same, right? Both the voltages are the same because they are both connected to the same dry cells. Did you understand that? Okay. Base collector connect වෙලා තියෙනෙත් එකම dry cell set එකට base, sorry, let me rephrase that. Emitter collector connect වෙලා තියෙනෙත් එකම dry cells වලට, emitter base connect වෙලා තියෙනෙත් එකම dry cells වලට. So because of that මේ circuits දෙකේම එකම current එක තමයි flow වෙන්නේ. ඇයි එකම current එක flow වෙන්නේ? Because they are both connected to the same set of dry cells. හැබැයි ඒක avoid කරන්න තමයි අපි මෙන්න මෙහෙම කෙනෙක් connect කරලා තියෙන්නේ. කවුද? This very high resistance. If there's another resistor, the current won't be the same because the current can't be the same ළමයි. ඇයි ඒ? ඔගන්ට මතකද අපි මුලින්ම කිව්වා බේස් එකයි එමිට් එකයි අතරේ තියෙන වෝල්ටේජ් එක අඩු වෙන්න ඕනේ නේද මේ වෝල්ටේජ් එකට වඩා? මේ වෝල්ටේජ් එක අඩු වෙන්න ඕනේ මේ වෝල්ටේජ් එකට වඩා. Otherwise the transistor will not work. හැබැයි දැන් තියෙන විදිහට දෙන්නම එකම resistors වලට connect වෙන හින්දා දෙපැත්තෙම voltage එක එකයි. But this should have a lesser voltage or a lesser current than this. ඒකින්ද තමයි ළමයි අපි 22 kilo ohm resistor එකක් connect කරේ. Now collector එක connected to this positive terminal, emitter is connected to this negative terminal, so they get this voltage, no problem. හැබැයි base එක ගත්තොත් emitter is still connected to this negative terminal, base is connected to this positive terminal ම තමයි. හැබැයි ලොකු resistance එකක් තියෙන හින්දා මෙතනට set වෙන්නේ චූටි current එකක්. IB will be very small. Why? Because of this very large resistance. ඒක collect එකට නෑනේ resistor එක. Only for the emitter there is this resistor. Therefore very small current will flow through the input circuit. Did you get it? Anybody who did not understand that? Okay. ළමයි මේක ඉතුරු ටික අපි ඊළඟ ක්ලාස් එකේ ලියමු. So ඊළඟ ක්ලාස් එක will be, now I told you Saturday class එකට එක සතියක් miss වුණා last month. Sunday class එකටත් last month එක සතියක් miss වුණා. That is why I decided to combine the two classes. ඒ catch up එක කරන්න තමයි මම මේ slot එක දාගත්තේ, right? But a few of y'all had some concerns regarding the time, so we will finish at 10, right? Normal class time එකම අපි ගමු. So එතකොට Saturday class ළමයින්ට Saturday මේක ඉතුරු ටික කරනවා, Sunday class ළමයින්ට Sunday මේක ඉතුරු ටික කරනවා, right? එතකොට I will explain this signal amplification situation again one more time. දැන් අපි explain කරානේ. තව පාරක් explain කරන්න ඕනේ. මේ capacitor එක තියන්නේ ඇයි කියලා කියන්න ඕනේ. මොකද්ද මේ AF generator and AF signal කියන්න ඕනේ. ඒ ටික I will explain the next day. I will share the whiteboard with you all too. I know some of you all joined a bit late, so you might want the recording, which you of course have to request. මට පොඩ්ඩක් මතක් කරලා ඉල්ල ගන්න. Don't leave. Before we end the class, is everything clear? Whatever we did today, is everything clear? Nudam, Randira, Manisha, Batula, Imasha, Oneli, Ansilu, Muni, Mikeli, Dinugi, Senet, Disal, Ashwini, Sehasha, Sanuli, Setumini, Kalna, Pamodi. All right. So, Lamai, Saturday, Sunday, both the classes will be 7 to 10. Right? Saturday class at 7 to 10, Sunday class at 7 to 10. We will be continuing the rest of it, starting the class, right? And past papers, Ogalan and Deka Kina Chutta Kehana Mahata Velati, and Ekina Tamatamanda Dipu homework Karangenda. And I'm pretty sure I gave you things to study, right? So please study those and come. I told you, whenever I asked you to study something, take it as an opportunity. හොඳ වෙලාවට මිස් මේක දුන්නේ ඒකින මම දැන් මේක පාඩම් කරනවානේ කියලා. Take that opportunity and study those and come because I will be testing. සමහර අයට මම දැනුවත්වම I know that I have to send some recordings, like for an example this ultimate pollination recordings එවන් තියෙනවා. And then I think තව කාට හරි මට මතක විදිහට එවන්න තිබ්බා. ඒ අරන්න මට මිස් වෙච්ච ඔයාලා තාම රික්වෙස්ට් කරලා එවපු නැති recordings තියෙනවා. මට චුටි message එකක් දාන්න. Disage pollination recordings are second recording I couldn't find it, so I will quickly look at like check my recording set and I will send it to you. Yeah, so that's all, and we will end the class for today. So until we meet next Saturday and Sunday, have a great time, study well, and see you in the weekend. Bye, Lamai.